Let's choose, whoops. You choose another one from the textbook. You won't see it, but I don't think that matters. And I've lost it. Okay, I'll just make up some of my own then. I think that's probably just as easy. Suppose we got secant x plus 1 over cos x. Don't want anything else, maybe. Yeah, let's try that. Now, not really an awful lot happening here that you can really change. That guy there is probably a good idea just to leave. Is there anything you could see that a secant might turn into that might be useful in this question?
1 over cosine.
Now, you're going to have to deal, especially with the later questions, not with the earlier ones, but with the later ones, you're going to have to deal with these weird fractions that have fractions in them. In this case, can you see the top guy has a 1 over cosine in it? And so there are algebra ways in which you can take care of this. And the technique I like a lot is by multiplying the top and bottom by a special version of 1. As long as you multiply something by 1, you don't change its value. You kind of change how it looks, but not its value. So I'm going to multiply the top and bottom by cosine x. So you agree that's 1. So whatever I'm multiplying this fraction by, I can multiply it by 1 and it won't change its value. It will just change how it looks. Well, cosine x times 1 over cosine x gets me 1. And cosine x times a 1 gets me cosine x. And on the bottom, I'm not going to do anything yet. I'm just going to write it down like that. Now, do you see anything interesting on the top that might cancel with something on the bottom?
Both of the parentheses, because it's just the same thing.
Yeah, they're just, the order's different, but a plus b and b plus a are the same thing. Now, does that leave behind a cosine x or a 1 over cosine x?
1 over.
And this is the bit that people don't like, but they have to know it. One of the rules of simplification is that you should try and never write a trig function as a fraction. So this fella ends up just being called secant. Does that make sense?
Yeah.
Yeah. So you never leave an answer as 1 over sine. You call it cosecant. You don't even leave it. Imagine this is a different question. You don't even leave it like that. So one of the rules of simplifying a trig expression is to make sure that you don't, if it's at all possible, sometimes you can't avoid it. If it's at all possible, you try and avoid having fractions. So you simplified it down to 1 over cosine x, and you're really pleased with yourself, and then you try it in the computer, and you say, oh, I wonder what I did wrong. Actually, you didn't do anything wrong. You just didn't take it that last step in the process. Are we good?
Yep.
Yep. Right. I'm going to just kick on something and see if I can get it to work. So what I'm doing right now, though you can't see it, I suspect you can't see it, is I'm going to look at some of the same questions, but from WebAssign. Because sometimes the WebAssign, the questions in their homework don't kind of match exactly the same kind of questions that you get in the textbook. And so the phrasing is a little bit different or something like that. So I just want to come and have a quick scan through what they look like. Okay, I've got it set up now, so I should be able to do it for you. I'm just being really extra careful not to hit anything like a close button, because that tends to do a lot of things I don't want it to do. So where are you hiding? You're here. Right, you should be, hopefully you're watching the same thing as I am, which is the homeworks from 7-1 now. Okay, right. Now, the answers are at the side here, which is just what I get when I get my version. So it says, write the strike expressions in terms of sine and cosine, then simplify. That bit in terms of sine and cosine, will you just imagine that every single question that you ever see might have that as part of the sentence, even although later on they don't do it. Now, in this case here, can you see that the only guy that's going to change, so this should be a really quick question, isn't the only guy that's changeable is the tangent? And what will it change into then?
Sine over cosine.
And then can you see the cosines cancel and boom, that's the answer?
Yeah.
Yeah, right. So now I look at something that I think I probably should do. I'm just going to write it down right now. It's a cosecant squared x. Take away a cotangent squared x. Right. And the answer is going to be 1, because I can tell it's 1 because it says it's 1. But let's find out how we would go about that one. Now I'm going to show you the long way, then I'm going to show you the short way, because sometimes you don't notice it until too late. If you take a cosecant, that gets you 1 over sine x squared x. If you take a cotangent, that gets you cos squared x over sine squared x. Are you happy with that guy is this and this guy is that? Are we okay with that step?
Yeah.
Right. Now, do you notice that these two fractions share a common denominator? So that becomes 1 take away cos squared x over sine squared x. We happy about that, like?
Yeah.
Now, what does 1 minus cos squared x also equal?
Sine squared.
And guess what's going to happen? Done. Okay. Now, that was basically, you might think that's a short way, but that's actually the long way. You know, if you go and you look up those identities that they gave you at the top of that chapter, one of them might not look like that, but one of them, if you rearrange it, is that one. I think they have a cosecant squared x equals 1 plus cotangent squared x. If you notice that one, you could do a one-line rearrangement and you'd say, oh, it's 1.
Yeah, that's what I noticed first, just because when I saw the squared on it, I thought that meant I had to use like the Pythagorean identities. I didn't think to just do the reciprocal of it.
Right. Yeah, the Pythagorean identities are the fancy name they call the sine squared plus cos squared equals 1 and the other two in that same family, right?
So if you have one, you know, like cosecant and cotangent, or maybe it's like tangent and secant, if you can just look at it, if it's set up like that and know it's going to be 1.
It'll probably be 1, or it might be tan squared. You know, if somebody says to you, secant squared x plus 1, do you know that's a rearrangement of the Pythagorean and the answer is going to be tan squared?
Yeah.
So it's, you know, it's a 50-50 chance. It's either going to be a 1 or it's going to be the other one of the 3, because there's always 3 things in these Pythagorean ones, right? There's a sine squared, there's a cos squared, and a 1, right? So depends on who you get, what the rearrangement's going to come out as. But 1 is going to come out half the time, and a tan squared, or it's equal to a secant squared, or a sine squared, or whatever the other piece is going to come out the other half of the time.
Okay.
Nothing good? Right, let's try, yeah, I think we get time to just have a quick scan through some more. This is the only ones I'm really focusing on right now. Now that one comes out as a number. This one's a little bit less obvious. So if you're looking at question 5, hopefully you're seeing what I'm saying, right? you've got a secant, a cosine, and a sine. And there's only one of those guys, right, that's going to be simplified or changed, and that's going to be the secant, right? So far, agree? The secant is the only one that we're going to change. So I'm just writing this guy down. So we have a secant theta, take away a cosine theta, and on the bottom, it's a sine theta. And according to the answer, when we're finished, we should get a tan. You won't see the answer until then. So we've already agreed that the only guy that we can really work with means that we now have that. Not very pretty. So I'm going to use my little trick that I used in one of the other questions. What would be a good version of one that I could use that would take care of this ugly fraction?
Cosine over cosine?
Yeah. So whatever you decide, it's the same guy top and bottom, right? It's not going to be one if you don't do that. Now, as I multiply through, a cosine times a 1 over a cosine gets me a 1. A cosine times a cosine being subtracted is a cos squared. And then I have sine theta. So far, so good?
Yeah.
And there, now it's good. I forgot the other cosine, in case you were opposing. What does 1 minus cos squared become? It's one of those Pythagorean.
Sine squared.
Right. See, after a while, it just becomes second nature. Now, do you see that we can cancel one of the signs? Not both, but just one. So that cancels one of these signs. And so that still leaves me a sine over a cosine. And the sine over a cosine is a tangent. It's a different kind of algebra, isn't it? It's trig algebra, where you start with ugly trig fraction and you try and make it nice trig fraction. Now, the ones we didn't have time to do today, the later section in this 7.1, what they do is they give you this guy and they tell you what it's equal to. And it's your job just to fill in the gaps in the middle. So you're being asked to prove that secant theta taken by theta. And I have just lost my mic, so we will call